Ubiquiti had a lot of strengths. We had hardware design, antenna design, mechanical design. We had firmware and software and protocol design. But the one thing we were missing was really our own radio design and our own modem design.
The group of guys that are here have been working together for about 20 years. We really collectively have, a lot of experience in the wireless data world, probably more so than just about any other company.
So this team of people were originally all hired into Motorola. Some of us go back to the late 1980s. We actually worked on a program called Ainter.
Ainter was one of the original attempts at doing in-building wireless networking.
That was the first wireless local area network product ever.
That was actually the first time that I'm aware of anybody built a wireless broadband product.
A lot of the work that we did on Ainter sort of continued on through Motorola and eventually became a product called Canopy. Canopy is a very popular product now. It is a wireless internet distribution system used to provide high-speed internet to people, typically in houses where there isn't access to cable or high-speed DSL.
We had kind of run the Canopy product through maturity, and I didn't see a whole lot of additional room for growth there. So the Ubiquiti team approached us.
And we were looking to continue to build new stuff. And so that's what made it very interesting to be able to come over and work for Ubiquiti, because their focus is the new stuff. It's working on high speed, it's working on low cost.
The freedom to design at our level is just go. What are you going to do? And it's like a clean sheet of paper, start with nothing.
We could build and design this product basically any way we saw fit. The idea was just to be the best we could. airFiber is a new product line inside Ubiquiti. This is the first of several products that are highly efficient, high data rate wireless broadband products.
Our design is something that's a little bit crazy. We're trying a 0IF radio at 24 gigahertz for 100 megahertz bandwidth, which is something that I'm not sure anybody else has been crazy enough to try.
As fast as you can send a packet on an Ethernet wire, we can receive it and we can transmit it with no limitations.
airFiber is designed to be mounted up in a reasonably high location. It's a point-to-point network where the two antennas see each other. This is a system that under certain circumstances can work up to maybe 10 miles.
It is going to be very easy to deploy and align. It's going to be a product that's going to require only one person to have to carry it up the tower and install it.
There's a display on the bottom that tells you what sort of power is being received, as well as a fairly comprehensive web interface.
We designed all aspects of it, the modem, the radio, the mechanical housing. This is a completely designed from scratch, purpose-built solution just to deliver backhaul. So it's not based on Wi-Fi or anybody else's standards-based solution. So it doesn't suffer any of the other overhead that you'd have to associate with that.
So if you want to compare the data rates of existing products to our product, many of the products on the market today would give you the data rates like you would expect from like a garden hose, the flow rate of water through a garden hose. Our product will provide the flow rate of a fire hose.
This product will do 1.4 gigabits of data, which is approximately 300 times faster than you would get from your normal home internet service provider. Operators are going to be able to get between 10 and 100 times more data throughput
for the same dollar. So that's the big impact that this product is going to have.
We looked at 24 gigahertz and we actually wanted to do something up in high frequency, and that happens to be the next unlicensed band beyond 6 gigahertz.
You can put it up anywhere. You don't have to do anything, no special paperwork, no licensing fees, nobody to go get permission from to operate the radio.
The nice part is it allows anyone to purchase a product and start it up without any issues of getting licenses or having certain hoops to jump through where you can place the product. It's a freedom thing.
As far as I know, nobody builds a modem with this level of sophistication. Most people, when they build a modem, commit to custom silicon that's very expensive, very time-consuming. It's also very rigid in its architecture. You can't reprogram it. And if you make a mistake or a customer wants to change a feature, it's locked in stone and it's too late once it's committed. We call this a modem, but there may be times when we can actually reload different software into it and actually change the identity of this piece of hardware on the fly. So it's programmable and it can be flexible and do basically whatever function you want it to do. Most systems, the farther you get away, the more time you have to wait for the packet to actually literally get from the transmitter to the receiver. Even at the speed of light, when you're 10 or 20 miles away, it takes a long time for that packet to get there. So we actually have a patent pending that allows us to synchronously send packets so that the transmitted packets from both ends of the link actually can meet halfway in between in space. It doesn't have to wait to receive the packet before it transmits. They're both synchronized to global positioning in this case, and they can send packets simultaneously.
In the developing world, there are many people who unfortunately have to will dig up the cables that go between various telecommunication centers trying to pull the copper for the scrap value. The scrap value of some of that copper, with the price of copper these days, could be more than a month's or 2 months' salary that normal people would have in those countries. When people are laying copper or they're laying fiber, the guy that's digging it up is not educated enough to know the difference between the two types of cable. And so he'll dig up the fiber cable, cut it, and then look and say, oh, it's not copper, and leave it and go. But the problem is he's just disrupted a significant amount of data traffic because he's cut that fiber. The nice thing about a wireless data link like ours is that you can secure both ends of the transmission link, and you don't have to worry about the mile or 2 or 5 or 10 miles in between. You don't have to worry about securing that and making sure nobody's digging up your cable, because there is no cable.
When you're given an opportunity to try to create something new, try to do something differently than someone else has done, as an engineer, that's always very exciting.
Ubiquity has a reputation for being very disruptive in the marketplace, and we found that very attractive.
We like to think about products differently than everyone else.
I think the thing that's really exciting about airFiber is it's the beginning, I believe, of what will be a number of products.
It's going to be a whole lot less costly and much higher performance than anything else that's out there right now. It's the way kind of Ubiquity does everything.